Today is going to be a special lesson because we are introducing our first attempt at pure mathematics paper 2. Tirikuda kutanga kuita vectors 2. Saka pakuita vectors 2 kwatiri kuita, we are going to be looking at further vector methods. Kureva kuti this lesson builds upon strongly on what we did patakaita vectors, which in essence is vectors 1. Saka vectors 2 topic inotestewa in ZIMSEC pure mathematics paper 2. Where do we start? Further vector methods is an extension of vectors 1, as we have just said. This topic places specific emphasis on the equation of a line and the equation of a plane. Saka, part of our objectives panaba, we want to learn two concepts. Chekutanga, we want to learn what is called the equation of a line. So equation of a line at skureva, equation of a line under coordinate geometry where it's y is equals to mx plus c. Tukureva an equation of a line which is linked to vector concepts. Then secondly, we are going to look at the equation of a plane. Equation of a line, equation of a plane. These are our objectives. Vector methods are grouped into two sections. Saka, the sections we are going to be interested in, the first section is determination of equations. Determination of equations. So our objectives is to learn about the equation of a line and the equation of a plane. So how do we determine the equation of a line? How do we determine the equation of a plane? That is what we are going to be looking at. Then the second concept, the second section of vectors 2 is going to be the application of vectors. How do we apply vectors? So the application of vectors, what we are going to do is more like mechanics. Kanakuti, we are going to be bridging mathematics and physics, learning how to apply vectors. Now the first thing we are going to do determination of equations. In the scope of today's lesson, we are going to do the equation of a line. Saka tiruda kuita determination of equations, which is the first section. Then specifically today, tiruda ku introduce equation of a line. Now the equation of a line in vector theory, it is made up of two parts. That is the position vector and the direction vector. So our first note, the equation of a line is made up of two parts. What are the two parts? Which are a position vector we all know what a position vector is. A position vector is a vector originating from the origin, and the direction vector. Sakayatiri kuti direction vector, this is the term we are going to be using, but certain mathematical literature inoti a displacement vector. Saka this direction vector is usually a displacement vector. Sometimes it is not, and we are going to explain what happens in those times. Then your syllabus calls it a free vector. but emphasis yedu kana kuti the term we are going to use which is not ambiguous, of course position vector and also a direction vector. Mapaona. Saka let us write down what is the general equation, then we are going to explain terms. Saka the general equation of a line in word form inenge ichiti r is equal to position vector plus lambda direction vector. R is equal to position vector plus lambda direction vector. Okay, let us define terms. Tanga tatotaura already kuti the two parts which make up the equation of a line, they are a position vector and a direction vector. But tiri not panapa we are adding this multiplier, the lambda. What is this lambda? Okay, before we go to lambda, let us define what we refer to as a position vector. A position vector describes any point that the line passes through. Saka kana chiti position vector, tiri kuti any point the line passes through. Sandorot mubatisise kuti when we are talking about a position vector, we are interested in where the line passes through. That gives us the position vector, and it has to be any point. So any point the line passes through. Whereas a displacement or a direction vector, we are going to call it a direction vector, is used to describe any direction that is parallel to the line. Saka kana takuti direction vector, S is in the term, trukutaura kuti it describes any direction parallel to the line. It's going to make sense when we begin to do illustrations. From there, R is equals to position vector plus lambda direction vector. Okay, saka we can also have a general statement, kana kuti the general equation of a line. But we want this general equation of a line now to be in mathematical form, with the symbols. And we find it to be what? R is equal to the position vector. Of course, turns out it's or something, let us say OA, and that's the position vector, plus lambda, then our direction vector, usually AB. Saka this is the general form. You are allowed to denote these as vectors, as is done there. Okay, let us give an example. We're going to work through examples from Darshan K Gendah, but for now let us just give a few scenarios. Saka, let us say we are given that point A and B have position vectors. Saka, for our scenario, and it given that point A and B have position vectors What are the position vectors? OA is equal to 3, 2, minus 1, and OB is equal to 2, minus 3, 1. So we are given these two position vectors. Scenario 1. What is scenario 1? Taudzwa kuti we want to find the equation of a line that passes through points A and B. So equation of a line that passes through the points A and B. So how do we find the equation of a line that passes through the points A and B? Chekutanga, we have to write down our general equation of a line, and I prefer we write it down like this. R is equals to position vector plus lambda direction vector. Saka I'm sorry, pani panaka ndisina kutsanangura, forgive me. Takatisina kutsanangura kuti lambda inorevei. I had forgotten. Saka lambda is a parameter for the direction. It's a parameter for the direction. That is what lambda is. And it. But you also have to bear in mind that other symbols can be used to denote the parameter of the direction. For instance, st, mu, and so on. And saka panapa mukatarisa, for example, in Darshan K Gendah, one of our source material, muchaona kuti they don't use lambda, they use t. Saka this lambda, it's merely a variable. It is replaceable. It can be replaced by other symbols like s, mu, t, alpha, whatever you want to use. But we prefer to use lambda. Sakataziwa lambda chi, it's simply a parameter for the direction. When you begin to do mathematics and science, you're going to find out that at times certain constants are used to balance off equations. Certain lambdas or variables are used also to balance off equations. Saka, we are not doing real analysis. We are not tasked to know why we have to put in a lambda, where the lambda comes from. We are not doing proofs. We just have to know kuti that is the position we are dealing with. Now, if we revert back to our question, Saka, kuti ti answer this question, irikuda the equation of a line that passes through points A and B, tinotanga tanyora kuti equation of a line yacho imborichi. R is equals to position vector plus lambda direction vector. That is what we begin with. Okay. Tanyora kudaro, what then are we going to do? Saka tati position vector chi. To define a position vector as a vector that describes any point that the line passes through. So mukaverenga question edu muchaona kuti this line ratirikuda the equation of it passes through the points A and B. Saka line redu rikuita pass through A, roita futi pass through B. Kureva kuti we are going to take the position vector of A because our line is passing through that point. Murukuzoona. Saka, for our position vector, R is equals to OA, toti plus lambda. Remember, lambda is more like a scalar multiplier. But we do not actually do the scalar multiplication. We are going to see what I mean. Then what about AB, the direction vector? To define a direction vector is a displacement vector which is used to describe any direction that is parallel to the line. Saka tikaverenga question yedu equation of a line that passes through points A and B, our direction vector is going to be AB, because AB is a vector which is parallel to the line. Then it is needful to do it like this. Muruguzona, R is equals to OA plus lambda AB. Okay, what is OA? OA and 3, 2 minus 1. So R is equals to 3, 2 minus 1 plus lambda. Remember that AB ngerichi destination point subtracting source point. You have to remember that. Saka panapa we are saying R is equal to 3, 2 minus 1 plus lambda. What is OB? And tinogona daiso to make it more smarter. Saka, what is OB? OB mukatarisa when you were following through writing notes, not OB into 2 minus 3, 1, which is subtracting OA, 3, 2 minus 1. Nditika? Saka R is actually 3, 2 minus 1 plus lambda. 2 minus 3 into minus 1. Minus 3 minus 2 into minus 5. 1 minus 1 into 2. Like that. Saka amadzangu, this becomes our equation of the line. Like that. Saka kana question yawe ichida kuti titsvage the equation of a line, your tools are the 2 points where it passes through. We are just going to take the first point as the position vector. Then we are going to take A and B as our direction vector. Then to evaluate, we get our answer. And kunevari keen munogona kutongotarisisa munotoona kuti this is so much similar to y is equals to mx plus c. I'll bet it will be more like y is equals to c plus mx, but we don't want to go there. We just have to know it like this. Okay, let us go to scenario number 2. Saka, for our scenario number 2, scenario 2 iri kuti kudini? Equation of a line that passes through point A and is parallel to OB. Saka, equation of a line that passes through point A and is parallel to OB. Okay, how do we get this? What is the equation of a line? R is equals to position vector plus lambda direction vector. What is our position vector? This is a vector that describes any point that the line passes through. Saka since tatoudzwa kuti our line passes through point A, zvoreva kuti automatically our position vector is OA plus lambda multiplying. Remember kuti direction vector taidefine as what? Direction vector taidefine as a vector that describes any direction that is parallel to the line. Saka kana panapa taudzwa kuti and is parallel to OB, zvoreva kuti OB ndiyo direction vector yedu. Saka that is the reason why tichiti direction vector, not displacement vector, even though it can be it is sometimes a displacement vector or a free vector. Saka this is a case where we have a direction vector which is not necessarily a displacement vector. How does it happen? Because tinenge taudzwa nequestion specifically kuti this line is parallel to a certain vector. That vector is our direction vector. So when you are doing this, it's fascinating. When you are doing this, mukaona the keyword passes, mobva matoziva kuti ndo pamuchawana chi your position vector. Saka whatever comes after passes is your position vector. Whatever comes after parallel is your direction vector. Those are mufanwa kuziva. Saka we have keywords. Zvikanzi passes, vangona kuti goes through or whatever synonyms, vai kuti vari kukupa ichi position vector. Zvikanzi parallel to, zivai kuti vari kukupa ichi direction vector. Vakakupai two vectors, an example being A and B, zivai kuti AB ndiyo chi direction vector. Saka you take hints from the question itself. Okay, so let us answer this question. We've explained it. Saka R, it's OA taudzwa kuti it's 3 2 minus 1. Then this is plus the lambda of OB taudzwa kuti it's 2 minus 3 1. Saka this will be simply our answer. Tinenge tatoita arrive at our answer. Now let us look at forms of vector 2 expression. Saka isusu takaita forms of vector 1 expression, pataitaura about vector form, column form, etc. Panapa takuda kuita chi, and also the coordinate form. Takuda kuita forms of vector 2 expression. So the equation of a line can be expressed in vector form, in the parametric form and Cartesian form. Saka there are three forms of expression, cannot 3 vector 2 expression forms. They are all important. What are they? Tine vector form, tine parametric. Remember pamaita calculus 1 makaita parametric differentiation. Saka we have what we refer to as a parametric form. Then lastly, we also have a Cartesian form. Saka, let us start with number 1, vector form. Saka vector form ndo yatanga tichidzidza. R is equal to 3 2 minus 1 plus lambda, this is the parameter of direction, minus 1 minus 5 2, like that. That's vector form. Okay, we are going to take the same vector, but this time we want to write it in the parametric form. Saka parametric form, we want to define it. We want to define all the components of a vector, kureva x, y, and z. And so the parametric form, with this form, an equation is broken down into 3 directions, x, y, and z. Saka, let us write it down. The equation is broken down into 3 directions, cannot dimensions. What are these 3 directions? X, Y, Z. So how do we do that? We want to use this. Saka zvatinongoita tinoda iso, we put these curly brackets and it tobva tati what is x equal to. Saka remember tiri pano you must know kuti this is x y z anditi. Saka x kureva kuti panapa we are simply going to say x is equals to 3 plus lambda multiplying minus 1 anditi. So x is equal to, it's 3 plus lambda multiplying minus 1. What about y? Y are equal to 2 plus lambda multiplying minus 5. What about z? Z are equal to minus 1 plus lambda multiplying 2. Then of course we are allowed to further simplify, our answer being x is equal to 3 minus lambda, panapa y is equal to 2 minus 5 lambda, then c is equal to minus 1 plus 2 lambda. Like that. Tinenge tatopedza. That's the parametric form. We are breaking down our equation into its directions. Okay, then for our number 3, which is the coordinate form, remember kuti coordinate form yanga yakambomira sei, yanga irichiti x y z. So how do we do it now in vector 2? Zvatinoita, this form is given by making lambda the subject of the formula. Saka make lambda the subject of the formula. In each equation direction. In each direction equation, I meant. In each direction equation. Saka, what do we mean here? Tirikuti, curly brackets again, lambda is equal to, antitika. Saka kuti lambda is equal to tikuzama ngokuudza kuti we are taking the value of, we are making lambda subject of formula in all cases. Saka lambda inge equal to chi, panapa it's x minus 3 over minus 1. I will explain kuti zvabvepi, which is also equal to y minus 2 over minus 5, which is equal to z plus 1 over 2, like this. Anditika? Saka zviri kufamba sei? Let us take our first form, because everything is being derived from our first form. Saka our first form, vector form, it's this. R is equal to 3, 2 minus 1, and then this is plus lambda minus 1 minus 5, 2. Like that. Saka panapa manje, we want to make lambda the subject of formula. Saka, how are we going to go about it? To make our life a lot easier, let us take this and make it parametric. Saka parametric turn out it's easier. Then c is equal to minus 1 plus 2 lambda. Saka panapa, if we make lambda subject of formula, pana x panapa, munoona kuti inenge ichiti lambda, because theta endesa minus lambda kuside uku, toendesa x kuside uku, is equal to 3 minus x. Like that. But another way of doing it, of course, tikaendesa 3 kuside uku ikava x minus 3 is equal to minus lambda, tikazo divide both sides na minus 1, tinoona kuti lambda inge equal to x minus 3 over minus 1. And saka kuti lambda is 3 minus x, zvakatongofanana nekuti lambda is x minus 3 over minus 1, because we know kuti tikaendesa minus kunoku, it will eventually be 3 minus x. Saka the idea pano ndeyekuti toda kutanga tanyora x, y na z. So that is why we have elected to do it like this instead of like that. So mukaita the same, mukaendesa 2 kuside ikati y minus 2 is equal to minus 5 lambda, you see that eventually lambda will be y minus 2 over minus 5, giving you this. Mukaendesa futi minus 1 kuside ichati z plus 2, then divide both sides na 2 to make lambda subject of formula. So that is how it is done. That is what we do with that. Okay, so let us just have 2 examples from Darshan K Gendah, then we call it a day. But we are also going to be having tutorials which are going to be looking primarily on the parametric form and also the coordinate form, so that munojairira kuti zvinoitwa sei. We have a question on our hands. Irikuti, write down the vector equation of the line passing through. Saka tataura kuti kana pakatoya the keyword passing through, zvoreva kuti that is our position vector. Saka since tikuda kunyora a vector equation, tinogona kutotanga tatoti r is equals to position vector plus lambda direction vector. And then position vector is the vector which comes after passes through. Saka position vector is equal to a 2 4 3, which will be OA being equal to, in column form, 2 4 3. And it was only with the direction vector. Saka kana watotipa direction vector directly vaita tsitsi. Saka direction vector tatoudzwa kuti it's equal to, in column form it's 1 minus 1 3. Saka therefore r is equal to position vector 2 4 3 plus lambda direction vector 1 minus 1 3. Zvatopera. It's as easy as anything else. Tatopedza question yacho. Let's go to the next one. The next question irikuti, the position vectors a and b relative to an origin O are, saka let us write them. OA is what? In column form ingeri 1 2 3, because pana I plus 2j plus 3k, and OB in column form ingeri 3 4 5. Saka taudzwa kuti these are position vectors respectively. Find the vector equation. R is equals to position vector. Saka mukakunzi find the vector equation, this is what you use. Do not try to write it parametrically or try to write it in coordinate form, because maona kuti we derive the parametric form and the coordinate form from the vector form. Saka use the vector form plus lambda direction vector. You can put it like this if you will. I think that will be more safer. Saka r is equal to, saka once find the vector equation of the line through a and b. So r is equal to OA plus a and b ndio inenge direction vector yedu, not forgetting that this should be multiplied by lambda. Saka r is equals to, what is OA? 1 2 3 plus lambda, what is AB? OB subtracting OA, destination minus source. Saka eventually r is equal to 1 2 3 plus lambda, OB indian 3 4 5 subtracting OA indian 1 2 3. Saka this is no, got it's k. Saka r is equal to 1 2 3 plus lambda 3 minus 1 2, 4 minus 2 2, 5 minus 3 the 2 foot. Saka zvatodi zvatopera. Kana zvadai so zvinenge zvatopera. In our next lesson, what is going to be our next lesson? It's important for you to know what our next lesson is going to contain. Of course, what is going to come next are at least 2 tutorials kuitira kuti practice the coordinate form and also the parametric form. But our next lesson, the content is going to be on the equation of a plane. Okay, if you have derived benefit from this, may you please consider liking, subscribing, sharing. If you want to join our class learning pure mathematics, advanced level ZIMSEC or Cambridge, please WhatsApp us on the number I am just writing down now. Otherwise, thank you and have a great day.